Hi friends, welcome back to new session. So in this session, let us see EMF equation of a DC generator and in a DC motor also because of generator action some EMF will be induced. That EMF can be called as back EMF. And let us see relation between the speed of the motor, back EMF and flux. And similarly, let me see relation between electromagnetic flux and IA. In addition to this, let me start characteristics of DC motors. Okay, that is first of all EMF equation of DC generator. Okay, so guys, in DC generator, because of generator action, some EMF will be induced. So there is no need to derive all those things. Let me directly see the equation. E is equals to pi z n p by 60a. Here pi means average value of flux per pole. Z means total number of conductors. To be frank, total number of armature conductors. And n means speed in RPM. P means number of poles. A means number of parallel paths. I already told you in the construction of DC machine itself, for lap winding, number of parallel paths A equals to M into P, where M is flex, M equal to 1 for simplex winding, M equal to 2 for duplex winding, M equal to 3 for triplex winding, and so on. For wave winding, once again, number of parallel paths A equals to 2 into M. Once again, M is flex, 1 for simplex, 2 for duplex, 3 for triplex, and so on. Let us see here. What about easy? Easy means average value of induced EMF. Okay, and try to see in a DC motor also. In a DC motor also, because of generator action, some EMF will be induced. That EMF can be called as a back EMF. So that back EMF formula once again just similar to that of easy formula, pi z np by 60a. See, try to understand here. Once design is completed, a number of conductors are constant and number of poles are constant, number of parallel paths are constant here. And what about remaining things? I can write here EB proportional to pi into n. From this I can write n proportional to EB by pi. This relation what I wrote here is a very important relation for problematic point of view in DC machines. So many questions are asking based on this relation. Okay. And see guys, n proportional EB by pi. And what about nomenclature? So what about pi? What is the nomenclature for pi, z, n, p, c, I mean a, all those things? Simple, just whatever pi I told here, z, n, p, a, same thing here only. That's why I'm just giving some detail marks like this. And what about EB? EB means back EMF in volts. Okay. And EC means what? Generator voltage in volts. Okay. And see one more thing. So please tell me, in a DC motor, because of motor action, some torque is developed. The torque only I'm calling it as electromagnetic torque. Electromagnetic torque is equals to mechanical power developed in DC motor by omega, or I can say yeah, okay. And see, tell me what about here? P mech is equals to I can write omega into T equals to P by omega. No, so P mech is to omega into Tm. So try to understand, guys, here. Okay, so please, one more thing, for what is the formula for P mechanical means, mechanical power developed in a DC motor means. So here very simple, P mech is equals to omega formula what? 2 pi n by 60 angular velocity into Tm. That means simply I can write here 2 pi nt by 60, no? 2 pi nt by 60, where T means what? Electromagnetic, 2 pi nt by 60. This only I wrote here, 2 pi nt by 60 is equals to, so what is the gross mechanical power developed formula? If you want me to write electrical equivalent of gross mechanical power developed in a motor means back EMF into IA. So I am writing EB into IA here. So from this electromagnetic equals to, simply I can write here EB means EB into IA. Yeah, EB means this value pi Z NP by 60 into IA. Okay, into 60. 60 will come here by 2 pi n. This 2 pi n will come denominator. Yes, okay, 2 pi n will come here. Okay. Let me cancel n 60 60. So ultimately you are getting so you are getting what? Electromagnetic, because what you are getting here? Pi Z P by 2 pi A into IA. So as usual, once reason is completed, number of conductors are constant, and number of poles are constant, number of parallel paths are constant. Simply I can write Tm proportional to flux into Ia. Tm proportional to what I can write? Pi into Ia. Once again, guys, this race is very important for solving problems in a DC machines. Okay, if you observe clearly, in DC machines, whatever the previous was asking in GATE examination, IS examination, most of the questions are coming from a speed control of DC motor. So that too, if you know these two relations, n proportion to EB pi and T proportion to pi into IA, so maximum questions can be solved. Okay, so that's why n proportion EB into EB by pi and T in proportion to pi into IA are important relations you have to remember. Okay, so now let me explain characteristics of DC motor. So for explaining those characteristics, I need this equation proportion to EB by pi, and I need T in proportion to pi into IA. So let us see. Let me proceed. So for DC shunt motor, let me explain first of all N versus IA characteristics. Then I'll go for T versus IA characteristics. Then I'll go for N versus T characteristics. Okay, for DC shunt motor. Similarly, I'll go for DC series motor N versus IA curve will see. Next N T versus IA and N versus T will see. So similarly, we'll go for DC compound motor also N versus IA and T versus IA, and I can say yes N versus T curve. So this for cumulative compound motor N versus IA curve, and for differential compound motor N versus IA curve. Okay, let us see if we start we can understand clearly. NT versus IA curve, N versus T curve, all those things for differential compound as well as for cumulative compound. See, if you see this previous curve, in this N versus IA curve, if you see there differential compound is there and a cumulative compound motor is there. And similarly, T versus IA curve, if you see for cumulative compound motor, differential compound motor, N versus T curve for differential as well as for cumulative compound motor. And I'll show all N versus IA curve for all four motors in one graph. Similarly, N versus T I'll show in one graph, and T versus IA also I'll show in one graph. Okay, so let me proceed. Yes, first of all, let me take a DC shunt motor. Okay, you know DC shunt motor. So the supply is given here, plus minus DC supply is given. IL, it will divide as IA and ISH. And you please tell me, guys, what is the formula for ISH? ISH means this voltage. I mean, across this voltage, across shunt field winding. What is the voltage means? You can say that V by RSH. IS is equals to V by RSH. And you see, as long as supply voltage is constant, your ISS remains constant here. So flux remains constant. So N proportion EB pi, already you know relation in the last slide only I told here, N proportion EB pi. I mean, whenever pi is constant, I can write N proportion to EB here. Okay. And see here, one thing you have to remember. For DC shunt motor, for DC motor, especially for DC shunt motor, I can write V equals what? I can write EB plus IARA. From this EB equals what? V minus IARA. Okay. So please try to understand, guys, here. Try to N proposed EB relation from this N proposed in place of VP, what I can write here? V minus IARA. So here, let me ask one simple question. For DC shunt motor, no load speed is finite or infinite? That is what my simple question. Okay. For DC shunt motor, no load speed is finite or infinite? Very simple. It's a finite speed only. What is the reason? And no load means though you take IA value 0, so this term may become 0, but N proportion to V, N proportion supply voltage is there. So definitely N value is not infinite. It is some finite value is there. Therefore, with no load speed is limited for DC shunt motor. That's what you have to remember. Yes, let me first of all draw N versus IA curve, N versus IA. IA means, guys, there is no need to write every time. IA means indirectly taking is as low. If you see for DC shunt motor, as mechanical load increases, current taken by the motor also increases, IA also will increases. So your IA 0 means I can take it as a no load condition. IA value is IA rated means I can take that condition as a full load condition. Okay, full load condition. So please try to let us first of all see without armature reaction, then I'll go for with armature reaction. So guys, without armature reaction, without armature reaction, see here, no doubt N proportion EB pi relation, I taken flux as constant here because I told you already IS is constant, flux remains constant. N proportion to V minus IARA. So whenever IA is 0, N proportion V is there, some limited speed is there. That's why I'm just taking no load speed this much value. And guys, as load increases, means as IA increases, as IA value increases, IARA increases here. So what will happen? N value will reduce. So that's why you're getting this drooping characteristics. I think you are able to see. Otherwise, I can use laser point here. As IA increases, IARA drop increases, N value reduces. That's why you're getting this drooping characteristics without armature reaction. Okay. And let us see with armature reaction. Already, I think I told you in armature reaction itself. Because of armature reaction, demagnetizing effect will come into picture. Because of that, flux will reduce. Because whenever flux is reducing, n value will increase. So I told you, I don't know how many if you remember, with armature reaction, if you see, whenever because of demagnetizing effect, flux is reducing, n will increase. So guys, try to understand here. So here with armature reaction means I should take a demagnetizing effect into account. That's why please try to keep a flux value in this equation. Don't remove this pi, because with armature reaction means you have to discuss about flux only. Therefore, let me keep a flux in the equation n proportion be pi. And I told you, whenever flux is increasing, because of armature reaction, whenever demagnetizing effect is there, flux value will be reducing, n value will be increasing. N value increasing means, don't, some people are thinking like this, n value increasing, no, so that's why they draw like this. No, don't draw like this, I mean to say n increases means, what is the meaning for this? N increases means, what is the meaning for that means, I'll tell you. No doubt guys, as IA value increases, n will reduce only. But here why I'm writing n increases means, n increases in the sense, with armature reaction, variation of your n, okay, with respect to your without armature reaction, variation of your n, with armature reaction curve will be somewhat above. It will be above without armature reaction, but variation is it is reducing only. As IA is increasing, your n is reducing, no doubt in that. As load increases, speed will be reducing only. But why I'm writing n increases means, I'm just comparing without armature reaction. So n increases in the sense that is with armature reaction curve. It means I mean to say this radical with armature reaction curve is above without armature reaction curve. That's the reason why I'm writing here. This increasing for speed indicates that with armature reaction curve is above without armature reaction curve. So please don't draw like this, okay, increasing like this. It is not, no doubt, as the IA increases, obviously n is reducing only. But this increasing of n indicates that with armature reaction curve is above without armature reaction curve. That's the meaning for that, okay. And let me draw T versus IA curve. Yeah, T versus IA. You know, let me take first of all without armature reaction. Then I'll go for with armature reaction. Okay, guys. Right. T proportional to pi into IA. So let me take flux value is constant in DC shunt motor. I told you flux is constant. Let me take flux constant. So T proportional to IA. So try to understand, whenever T proportional to IA relates from this relation, it is easily understand that as IA increases, what will happen? Torque will be increases in a linear fashion. See, without armature reaction, your green color curve, it is a linearly, it is increasing. Torque is increasing linearly. This is for without armature reaction. Now my question for, let me discuss for with armature reaction. With armature reaction means, guys, let me take T proportion to pi into I relation. I told you with armature reaction means, because of demagnetizing effect, you have to take flux variation into account. So let me keep flux in the equation. And you know, because of armature reaction, because of demagnetizing effect, flux will reduce, torque will reduce, okay. Torque reduces, okay. Reduces means, once again, don't draw like this, don't draw downwards, okay. It is not correct. Reducing in the sense what? This with armature reaction curve will be below without armature reaction curve. That's the meaning. See, previously I told here for speed variation, I told increasing, you are getting increasing. With armature reaction curve is above without armature reaction. I'm just getting torque reducing here. That is with armature reaction curve is below without armature reaction curve. Okay. So this increasing, reducing symbol, variation indicates that your curve is above or below. That only it indicates. Okay. Yeah. And see, guys, one more thing you have to observe. For with armature reaction, if you see at light load condition, I mean to say at light load conditions at this region, whenever IA value is low, in those conditions, if you see, your variation of your T is same for without and with armature reaction, because almost all negligible. See, under light load conditions, though armature reaction is there, though demagnetizing effect is there, though flux is reducing, that is not more dominated. So armature reaction effect is more predominant in high load, I mean at large load conditions, not at light load conditions. Okay, so that's the reason why your variation of T is almost the same for without armature reaction and for with armature reaction under light load condition, because armature reaction effect is less, demagnetizing effect is less, so flux variation is almost all negligible. So let me draw almost all same for without armature reaction, with armature reaction. Please try to draw variation of torque same for without armature reaction, with armature reaction. But But where it is more dominated at large load conditions, let me take like this. At a large, at large load conditions, I can say at large load conditions, at large IA values, armature reaction effect is more, demagnetizing effect is more, reduction of flux is more, torque will reduce. Yes, now here you can see variation of your torque. You can easily have different. Variation of torque. In the variation of torque, so definitely difference is there for without armature reaction and with armature reaction. See, at large load conditions, since because of DM effect, flux is reducing a lot, torque is reducing. Therefore, this curve will be, it is reducing in this manner. This for with armature reaction case. Okay, guys. So this with armature reaction curve is below without armature reaction curve. That too, that is more dominated at large load conditions. Okay, guys. This is for N versus IA and T versus IA. And let me take N versus T. N versus T. So this N versus T is almost the same, just like N versus IA only. Let us see. So N versus T, if you want, I need N equation in terms of torque. Okay, but let me discuss first without armature reaction, then I'll go for with armature reaction. So as usual, guys, please try to see what is the relation for N N proportional EB by and I told already flux is constant in a DC shunt motor. So in place of EB, what I can write V minus IARA. So but this is N equation in terms of IA, but I need N equation in terms of torque. Okay, torque. Okay. So T proportional to pi into IA. So once again your pi is constant here, T proportional to IA. So torque equal to some constant K into IA. From this IA equal to what I can write? T by K. So N proportional to V, okay, V minus in place of IA, what I can write here? T by K into RA. So please try to understand N proportional to V minus T by K into RA. So ultimately now you can draw N versus T curve because I'm having N equation in terms of torque. So now tell me, guys, whenever torque is 0, this term may become 0. See, XI torque, no, whenever torque is 0. So this T by K into RA becomes 0. But N proportional V only, some limited speed is there. So that's the reason I'm just showing finite speed here. Okay, finite speed. It is not infinite. Because N proportional to V, though torque is becoming 0, N proportional to V is there. So some limited speed is there. That's why I'm just, though torque is 0, N value is finite. And as torque increases, this minus term is increasing, N will be reducing. Yes, this is without armature reaction curve. It is reducing. It's having drooping characteristics. Okay. Now let us discuss with armature reaction. So I told you, if you are taking with armature reaction means, if you are taking armature reaction into account means, you should think about demagnetizing effect. You should think about variation of your flux. That's why try to keep flux in the equation as it is. N times EB pi, EB means V minus IA RA by pi. T proportional to I can write a pi into IA. So torque equals to some constant K. Okay, constant K into pi into IA. From this I can write, if you want, I can, already I wrote here K, no? So if you want, you can write here K1, nothing wrong. T equals to constant K1 into pi into IA. IA equal to torque by K1 into pi. Now in place of IA, T by K1 into pi, I can substitute in this equation. So N proportional to V by pi minus, in place of IA, what I can write here? T by K1 into pi. Already pi is there, pi square into RE. Okay, guys? So this is what I can write equation. And so please tell me, with armature reaction, it's easily, I told you, I already told you that with armature reaction, so because of demagnetizing effect, flux is reducing here, so N value is increasing. Once again, increasing in the sense what? That is with armature reaction curve is above without armature reaction curve. That's the meaning. With armature reaction curve is above without armature reaction curve. Okay, these are the characteristics for DC shunt motor. If you observe clearly here, note. See, direction of rotation of DC shunt motor can be reversed. See, already T proportional to pi into IA is, okay. If you want to reverse the rotation of shunt motor, that can be possible by changing either field terminals. If you change field terminals, flux will be changes, okay. That means in place of plus, it becomes minus. So torque becomes negative. So, I mean, definitely motor will rotate in reverse direction. So, suppose instead of changing field terminals, you can change armature terminals also, so that IA will reverse. So torque also will reverse. Tm proportional to pi into IA. Suppose if you reverse IA with armature terminals, torque becomes negative. So try to understand, guys. Direction of rotation of DC shunt motor can be reversed either by changing field terminals or armature terminals, but not both. Tell me what will happen if we reverse both the field terminals and armature terminals. If we reverse armature terminals and the field terminals both, this becomes negative, and this also becomes negative. It becomes positive once again. Okay, so please try to remember, direction of rotation of DC shunt motor can be reversed either by changing field terminals or armature terminals, but not both. That's what that is very important. You have to remember. Okay. And one more thing, let us see N versus IA curve so that you will be having some clarity. In N versus IA curve, if you see this N, IA means I can take it as armature current or indirectly, so you can take it as depending on if your mechanical load is varying, IA current is also varying, no? So as the mechanical load increases, okay, IA increases, N is reducing. N is reducing. That too, you are having grouping characteristics, no? Let me example with armature reaction. So no load speed is this much. And what about for with armature reaction? But with armature reaction, let me take at IA rated. IA rated value means indirect is nothing but full load condition only. Okay. So no load speed is this much. Full load speed means how much? So almost this much. No, this value. Okay, guys. So there is almost from no load to full load. Definitely speed is reduced. No doubt in that. From no load to full load, speed variation is there. But that speed variation is almost negligible. Suppose if no load speed is example 1000 rpm, your full load speed will be around 980, 950 rpm, something like that. So there is, I mean to say that from no load to full load, there is no wide range in speed. There is no wide range in speed from no load to full load. That's why I can call the DC shunt motor as a constant speed motor. Okay. So please guys try to see here application. From no load to full load, there is no wide range in speed. Therefore, it is used in lathe machines, drilling machines, shapers, spinnings, and weaving machines. To be frank, I can write a DC shunt motor. DC shunt motor can be treated as constant speed motor. What's the reason for that? Since no wide range in speed from no load to full load, there is no wide range in speed. That's why I can call the DC shunt motor as a constant speed motor. Okay, guys. So this is about characteristics of a DC shunt motor. In next video, I'll be proceeding explaining the characteristics of a DC series motor. Okay, and I'll go for in a DC series motor also I discuss N versus IA, T versus IA. Okay, and N versus T, and DC for DC compound motor also same thing. In DC compound motor, you are having cumulative compound and differential compound. For cumulative compound and differential compound, once again I will be discussing N versus IA and N versus T versus IA. So yeah, after discussing all those things, I'll draw N versus IA, N versus T versus IA in one graph. I mean N versus IA for all motors I'll show in one graph. N versus T I'll show all motors in one graph. T versus IA I'll show for all motors in one graph. Okay. In the next session I'll be discussing all the remaining portions and characteristics of a DC motor. After that I'll go for some observatory questions based on based on DC motors. Okay. Right. So I think for this session, this much is enough. I think in the next session, I'll be proceeding second characteristics of your DC motor. I'll start with the DC series motor. I already explained DC shunt motor. I'll be taking DC series motor, cumulative compound motor, differential compound motor. Okay, guys. Thank you.